Hello all, welcome to my channel. I'm back with another video. In this video, we will be doing a deep dive on Spark Shuffle service and how Shuffle works in Spark. Uh, so let's get started. In one of my previous videos, I have discussed this as well, but it was at a higher level that what Shuffle is and how it works in general at a very high level. In this blog, we will see how it is actually implemented and how the files are written into the Spark, because this is very much interesting to know is if you are working with external Shuffle service or if you are trying to improve certain things in this the Shuffle area, you need to know where the files store, how they are tracked, how they are stored in the disk, how they are buffered, and all those things. So let's get started. So let's say if we have an example that we want to do. Let's say we are joining two tables, and then we want to just show the joint data frame. So we have df1 and df2. We are just joining based on the join column, and we have set a shuffle passes to 4. So what will happen when this command is executed by Spark? It will analyze the logical plan. It will create a shuffle boundaries bit for the stages. It will create two shuffle map stages, one for each side of the join. It will assign a shuffle ID to each of them and launch the map task that write the shuffle files, which is nothing but data plus index files, and then launch a reduce task which reads those files and performs certain actions on that. So if we see the physical plan of this join.df, whatever is there, and if we explain it, so we will have one, see file scan one, which is for a CSV file that we are reading. There is another for the other part, other side. Then exchange has partition. This is where the shuffle will happen. Here also we see exchange has partitioning, where also shuffle is happening. Then there is a sort because it has decided to use a sort merge join. So there is a sort both side, and then it will be having a join, and then gets the result gets displayed. So this is the order. This is the physical plan that will happen. The key points to note here is the Spark has opted for sort merge join. Before each side of joins, there is an exchange, which is nothing but the shuffle, and the hash partitioning join it says 4 because we have set the SQL shuffle partition as force, because whenever the join is happening, when the redistribution of the join columns are happening, it is creating a hash partition on the four partitions is getting created. So repartition by join column into four different partitions. That is what it is doing in here as partition based on the join column. Now, this is where Spark will decide that okay, it must reshuffle the data of data frame 1 and data frame 2 based on the join column. And then it will sort both sides and join partition by partition. Each exchange will become a shuffle map stage with its own shuffle ID. So now let's go to the stages and shuffle ID task. So what is a shuffle map stage? So shuffle map stage is a stage where the input data is read from the source, records are assigned to a target partition, and the results are materialized as shuffle files on the disk. So there, here in this case, we will have two shuffle stages, one for df1, one for other df2, and the shuffle ID is just a numeric handle that Spark uses to name the files. For example, shuffle 2 means shuffle 2, and this becomes partition number, and then this is the data file number. So for example, shuffle 200 is one first, and then there's shuffle 3, which is first partition, and then the index. So that way it will create things. It will also track where the each map output is stored and help reducers know what to fetch. Map tasks and how many map tasks it will create. So for each shuffle map stage, Spark creates one map task for each input partition. So for example, if the df1 has two partitions, then it will create two map tasks, and if df2 has three partitions, it will create three map tasks, and those map tasks run on executors and is responsible for writing to the shuffle files. Now we have hash partitioning. So hash partitioning, it will take the hash, do the remainder, like do a modulo operator based on the number of shuffle partition that we have decided. So it is 4. So it will create 4 partitions. So Spark will apply the same hash function on the both side, df1 and df2, and it will keep on creating partitions, and then partition P, which will be handled by one reducer task. Okay, and that reducer can now join them locally. So that happens. Now, while creating this shuffle, uh, how it does in the map, block manager will be kicked in. So data in partition is first serialized, then it is put into in memory buffer. There is an shuffle external sorter as well, which sorts it. Then buffer fills, the memory pressure happens, it will spill to disk, and it will spill in this format, which is spill, and then the file data for number, and then it will say data, and also it will say spill of index. And then when the task finishes, it will merge all those spills to create a final shuffle based on the partition ID, and then also index. That is what will happen at the executor side. The things components which gets involved is block manager, which is a high level component that manages blocks, which is RDD partitions or shuffle blocks, broadcast blocks, and knows where to put the data, memory on the in the disk, and provides disk writers as well. Disk block object operators is also there, which is also actually writes bytes to the disk, and buffered writes to or commit or abort semantics is also implemented in here. Then we have external shuffle external sorter, which is for in-memory sort aggregator, whole serialized records, and this is done to make the process repeatable. So if we do it again, the orders would not change, and hence this sorter is used. Also, it knows when to spill and merges the sorted runs. So whatever sorted runs we have created. So this is this, if you see, this is the host of the machine where Spark job is running. Then we have an executor which is on this particular host. And in the inside that we have a shuffle map state. So sort shuffle writer writes to the does external sorting, uh, puts it into the memory, and once the memory buffer is full, it will spill to the disk. Like let's say three spill files were created, and then once this executor is going down, like it is finishing its task, then it will merge all these spill files into data files, and these data files will also have an index file. Spill files, how the structure will, like spill 0 0 index, spill 1 and 1 index, and then each file will contain the data for a particular or all the reducer partition from this map task. Layout will be spill 0 data like this, p0 bytes, p1 bytes, p2 bytes, p3 bytes, like that. And then it will index will store the each partition, where is the partition starts and ends. So these spills are temporary, and then once the final merge happens, these spills gets merged into a single data file which is for a partition, and then this is the thing that we will see once the executor finishes on the local directory. This is spill files, spill data and spill index, whatever was there that can be deleted, and we all have the shuffle data. The final file layout that will be looking in the data and index file will, like we have, if let's say four partitions, so p0 p1 p2, and let's say if size of each is 10 and 25 and these corresponding mbs. So what the shuffle data file will look like is that it will have first data for the partition 0 from 0 to 10 MB. Then from 10 MB's offset, it will have partition P1 data. Then from 35 MB, it will have P2. From 50 onward, it will have P3 data. So this is how the data will be stored, and the index will say the offset for P0 is what. Offset for P0 is from 10 MB, for P1 is 10 MB, for P2 is 15 MB, and then 8 MB. So this is the offset that it will store. That okay, for if I want to read partition P0, I will read from here till here. If I want to read P1, I will read from here to here. So that's how the index file will simply say, okay, go and read this section. So meaning P1 starts at 0, P1 starts at 10 MB, 35 MB, and 50 MB. So that is how the and how does the reducer know what to read? So it looks at the starts offset, then looks at the end offset, and then the length is in minus start, and then it will start to fetch the data. And this is how it fetches, like shuffle map. It will write to shuffle write processor, then shuffle data, shuffle index. This is on the writer side, and the read side it will shuffle. It will make a like ask that okay, give me the shuffle data. So it will fetch it. It will shuffle read and then provide it as a what you call view that we wanted to see, or if we have to write it, it will write somewhere else. So fetching and join happens as I mentioned. Reducer one each knows that okay, which reducer will process which partition, and then in this case, let's say that reducer 2, what it will do, it will fetch, it needs partition 2 from all df map task and all df1 map task. So let's say because we have four partitions, so reducer 2 let's say that okay, I want partitions shuffle id 2 and 3 from these two. So it will say from df1 shuffle data, this will read two slices, and then from dfb it will read these shuffle files three. This is shuffle id 3, and then three partitions, so it will read partition 2 slice, 2 slice, and 2 slice, and then it will go ahead and fetch. So it will ask the method or track the location of the shuffle file outputs. It will use the index file to find it, and block manager and shuffle client will do the sorting. If we are using external shuffle client, that shuffle client will also come into picture. Uh, Still on the reduce side, again, the when it fetches the data, reducer will fetch the data. It will deserialize, sort each side, and then it will do some sorting. So then flow is like this. So shuffle, it will call the shuffle service. It will read the shuffle read. It will do it in memory, and then once it the memory buffer is filled, it will say that okay, spill to disk. So reducer also can spill to disk. And what are these files on disk? Like it will like have reducer will have like block manager, then spill data, spill 0 index, and shuffle data like that will have the layout. So this is temporary spill files are while writing, then shuffle final will have shuffle, and the index will store in the means index stores the offsets for all the partitions, and reducer side will have some reducer side spills as well. So this is the whole flow of shuffle in Spark. Now we can see in Spark UI. So, for example, how to we can go to Stages tab in the Spark UI stages. We can look for description mentions as Exchange has partitioning, and these are the shuffle map stages, and that's how we can find. So, task 0 will say these are the stage files. You can also go to Executor tab in Spark UI executors, and we will see the shuffle metrics for each of the executors. Similarly, we can find out where the files will be stored. Is in the Spark local directory for the environment tab. If we look at this, we will find out where is the location that the files gets written. So this was it. This was a brief overview and deep dive internals of how the shuffle happens in Spark. Where do they keep those files? How the files are organized? So let's say if you are having too much of shuffle in one of your jobs, or let's say you are running a multi-tenant cluster and you want to find out which uh, shuffles are, let's say these shuffle files are filling up the disk and you are getting common error is disk running out. So if let's say if you want to add an application ID for each of the shuffle partitions, you can add it in here. Like that on the disk. So instead of mount local directory, Spark application ID, and then in the block manager, if you want to add something like the which stage or something, that can be done. So this is one good thing to know, that where it is stored and how it is stored. Hope this was just helpful. If yes, do subscribe to the channel and spread the word. Keep rocking. Thanks.